Today we're going to talk about how the United States military uses nanobots and nanotechnology to help our soldiers and to save their lives. My name is Rose Collins and I'm a student at UW-Milwaukee and I'm taking a course called Information Resources for Research. The United States government shows strong interest in the development of nanotechnology and nanorobots, also referred to as nanobots. So much so that in the proposed budget for research and development of nanotechnology in the military for the fiscal year of 2012, the budget was proposed for $1.7 billion. The following year, 2013, the budget proposed $1.8 billion towards nanotechnologies and their development. Now, what this means is that the United States government continues to put effort and believes that these technologies are only going to grow. Nanotechnology and nanobots will revolutionize our soldiers and civilian lives forever. How does the U.S. military use nanobots and nanotechnology to help our soldiers and save their lives? The key aspects discussed further will describe how we use nanotechnology, the current technologies that are being implemented, the technologies that are being researched and developed, and also the future scope of nanotechnology and nanorobots. What is nanotechnology? Nanotechnology is not simply working at even smaller dimensions. Rather, working at the nanoscale enables scientists to utilize the unique physical, chemical, mechanical, and optical properties of materials that naturally occur at that scale. Matter at the nanoscale behaves differently and can be reconstructed, built, and strengthened at the small scale it's at. Nanoparticles can only be seen with powerful specialized microscopes. At such a scale, the function properties of the material such as melting point, electric conductivity, magnetic permeability, fluorescence, and chemical reaction differ than those of conventional scale. This idea of difference is called the quantum effects and quantum physics. A team of researchers led by Harvard University is working on a project called Quasar, Quantum Assisted Sensing and Readout for DARPA, the Defense Advanced Research Projects Agency. The team has been successful at creating an environment entirely tailored to sensing and imaging at the nanoscale. The environment consists of shrunk equipment and it removes temperature constraints so that the team can get better quality of imaging. The team has succeeded in gathering detailed display down to the 400 nanometer, which converts to about the size of 2 measles viruses. Nanobot technology is possible because the human cell is magnetic. It can be charged a positive or negative charge that can alter the way that it behaves. Penn State University was successful in creating nanobots with motors to propel their way around in a swimming-like fashion. There was a video released on YouTube by Tom Malark, a professor of material chemistry and physics at Penn State. Each cell consists of organelles structured within a cell that performs specific functions. When these small nanoscale motors are powered with a high ultrasonic wave, they begin to crash into the organelles. The nanomotors can act as egg beaters to essentially homogenize the cell's content, or they can act as battering rams to actually puncture the cell's membrane. That being said, this revolution will mean that these nanobots will be able to go into the membrane of a virus or disease and annihilate it from the inside out. This research also shows that the nanobots can assemble in a straight line. When powered, they can spin cells in a fast rotating spin and assemble the cells in a row as well. Now here's the video that was released on YouTube by Tom Lark from Penn State University.
Nanomotors are controlled for the first time ever inside living cells. This video is a demonstration of a very active gold nanorod internalized inside the HeLa cell in an acoustic field. This video shows dot particles of the HeLa cell that interact with spinning gold nanorods. A team of chemists and engineers at Penn State University have placed synthetic motors inside human living cells. For this experiment, the team uses HeLa cells, which is an immortal line of human cervical cancer cells that typically are used in research studies. And the way they are using these cells is through electromagnetic steering together with high frequency. Our body is made of protons and neutrons, which are positives and negatives, and we are indeed electromagnetic vibratory creatures. The frequency comes from not only our environment, but everything vibrates. Frequencies everywhere around us, from the sun all the way to the darkest and deepest part of our solar system. You cannot escape frequency. Is it possible that some type of signal could be given to these nanomotors to be activated in the human body? It is possible. There's Gwen towers everywhere, cellular towers everywhere, and satellites to beam any kind of frequency they wish to through various techniques, from your TV to your computer to your cell phone. So it's no secret. All the articles are out there that this is possible. To see this in actual real life is amazing, because you can see how these nanomotors and nanobots can actually attack not only human cells, but attack our humanity, period. This team has been working on this for the past 10 years. They have been working on this experiment and study for the sake of good, because if you actually take and put effective medicines in these nanomotors, then you can technically target specific areas and heal. Is DARPA going to use this? YouTube is riddled with fear-mongering and videos of nanotechnology gone wrong. It is a possibility. I am not going to sit there and say that this is not a possible thing. Yet it is very intriguing that you see these cells acting the way they're acting once the nanomotors get attached to them. Now, all these videos are of the HELA cells, and they have been magnified up to 1,000% or 1,000 times magnification. And as you see, these nano motors under the proper frequency seem to be building some type of fibers or fibrous materials. And I wonder if there's any connection to the Morgellons victims. It is a possibility. I mean, this is scary stuff in a way, because it is us playing Frankengod. Frankengod is a reality when you come to this point. The transhumanist agenda is moving forward as always.
These nanomotors are in a long shape similar to a capsule pill and made out of gold. They propel using ultrasonic waves and steer using magnetic fields. There's also nanobots that are in the shape of a ribbon modeled after E. coli bacteria. This ribbon shape allows these nanobots to be magnetically charged and swim. Here's a little bit more insight into the current development of nanobots and nanotechnology.
We're making micro and nano robots that are guided by externally generated magnetic fields for use in the human body.
Brad Nelson is a mechanical engineer that likes to think small, very small. He's a pioneer in a field that's only existed for the last decade or so, nanorobotics.
To give you an idea how small these are, if I had a teaspoon, I could fit about 3 billion of them in a teaspoon. So
3 billion. It's kind of unimaginable.
it is kind of unimaginable, yeah. Well, the first challenges were how to make these things move.
The inspiration comes from nature, the E. coli bacterium in particular, which is propelled along by a rotating tail, or so-called flagellum.
Now, we can't make that motor. We don't have the technology for that. But what we brought in were some lessons we'd learned about magnetic fields and using magnetism to move these things. So we actually take these flagella and we magnetize them. And then we have a special rotating field, a special type of magnetic field we generate, which allows them to swim.
Having cracked propulsion, Nelson and his team worked on refining how the nanobots moved, how they danced. A waltz orchestrated on a nano scale. The nanobots are all manufactured in ultra-clean rooms like this, specially lit for the purpose. Machines to maneuver them about are also being designed and built. The target market is healthcare.
What you see on the screen here is an image through our ophthalmic microscope. of an artificial eye. And in the middle of that is what we call a micro-robot. It's about 1/3 of a millimeter in diameter, about 1 millimeter or so long, so very, very tiny. So this particular device was made to carry drugs, and so we can move it to any location on the retina, and then as it sits there, cause it to diffuse drugs off of it to a very particular location.
As well as our eyes, Nelson is targeting our hearts. An operation to repair damaged heart tissue is already planned for later this year. From one vital organ to another, he hopes his machines could be used in the brain.
So we've looked at applications, for instance, in deep brain stimulation and implanting electrodes in the brain, and we've looked at putting catheters within the vasculature of the brain.
And this could just be the beginning for Nelson's nanobots. He believes they could help us environmentally, something microscopic to tackle something massive, like an oil spill.
These are very small. If we can create swarms of them that can go out, they can cover a broad area. Water treatment, environmental cleanup, where you might be able to put hundreds, thousands, millions of these devices and have them swim through polluted water, catalyze pollutants, and then collect them later back. That's a particular application that's exciting. And
Massachusetts Institution of Technology, MIT, commissioned a research project called Institution for Soldiers Nanotechnologies, ISN. According to the ISN website, the Institution for Soldier Nanotechnologies is a team of MIT, Army, and industry partners working together to discover field technologies that dramatically advance soldier protection and survivability capabilities. ISN is funded specifically to use nanotechnologies to help our soldiers and save their lives. ISN has several projects that it has commissioned in order to come up with technologies to help the soldiers and save their lives. Project 3.3.2, Electromechanical Interactions in Blast-Induced Traumatic Brain Injury, looks specifically at the effect that blast interactions have on the soldiers' bodies at the cellular level in order that we can develop technologies to combat what occurs in the cell. The idea is that the nanobots will be able to respond to this type of injury as they occur in the body and prevent mental brain injury by acting immediately at the cellular level. When a blast occurs, the magnetic waves that are an effect of the blast have a crippling effect on cells. Nanotechnology will be useful to deter that effect. Once the blast occurs, nanobots will be triggered to respond and repair the cells. Another project titled Project 3.3.4, Predictive Multiscale Deformation and Injury of Soft Tissue, is focusing on looking to cell deformations of brain, cardiac muscle, and liver tissues that lead to injury. This project will be investigating how and why these deformations in the tissues are predictors of cells that will be more susceptible to damage. The project will use this information to be able to know what vulnerabilities cells have to specific occurrences that happen in real-life settings of the soldiers. Once the data is collected, nanobots will be better equipped to know exactly what to fix when each particular occurrence happens. Additionally, a project titled Project 2.1.1, Nanotechnology for Stimulating, Sampling, and Monitoring Immunity, holds promising for using nanotechnology and nanobots to help with immune cells and fight diseases. There are often local diseases that attack soldiers' immune systems while they are in recovery. They plan to use the following methods to accomplish these feats. Novel microneedle patch biopsy approaches to sample local immune cells from local tissue sites. Single-cell nanowell microengraving technology to analyze in detail the functional status of recovering live immune cells. This will be done with use of nanobot technology and distribution in the cells. Nanobots will make it possible to interact with live cells to help fight these diseases at the cellular level. Project 2.3.1, Nanostructured Biomatters for Treatment of Hemorrhagic Shock, is based on creating a hemostatic gel that is nanostructured and will stop blood flow and induce subsequent regeneration of tissue. This project is going to be the most beneficial to soldiers because the leading cause of death for our soldiers after penetrating injury on the field. According to the ISN, the material will be fabricating using novel artificial engineered protein polymer hyaluronic acid interpenetrating network hydrogels in order to mimic the properties of the natural extracellular matrix and provide an engineered platform for the incorporation of biofunctional signals into the gel. Also, the gel will be biodegradable and bioresorbable, meaning that it will not need to be removed after the application like current conventional methods. The gel will be designed to have high modulus, toughness, and resilience that are needed in order to withstand systolic blood pressure. Project 2.3.3, delivery of brain lipid nanoparticles using microtech devices for treatment of traumatic brain injury, proposes two methods of dealing with traumatic brain injuries in our soldiers. The first thing that is being looked at is nanobots that would be used to stimulate the neural tissues chemically and electrically. Advanced micromachining techniques and medical appropriate material will be used to develop these nanobots. The second technology that will be developed is the use of brain lipid nanoparticles. The nanoparticles are made up of naturally occurring brain lipids. The nanoparticles will be used as vehicles that would allow for local delivery of therapeutics. In the past, this was not a possibility because there was a lack of adequate routes of delivery into the injured tissues. These brain lipids are extremely vital in recovery. The hope for the future is that nanobots will be able to be injected into our bodies, into our bloodstream, through the brain, or through being swallowed. So here's a video that's going to talk a little bit more about what the future of nanobot technology is.
This is a little bit, we are starting from a little bit bigger size as an example.
Okay.
So this is a swallowable capsule robot, which has a camera on board, wireless communication, and it has...
a camera, you say?
Yes, there's a very tiny camera, the black part. So this, you see LED lights.
Where is the camera?
It's at the end here.
Okay.
And then there are small magnets inside. As you mentioned, to manipulate anything, you need some physical force. In this case, this capsule has magnets inside, and another external magnet can exert force on this capsule, and inside your body, this can be navigated. So it can roll inside your stomach, it can be stopped, it can go backward and forward as a robot.
Well, how would you put it in you?
So you swallow it. So it's a
You
pill size.
swallow it?
So yeah, this is completely wireless robot, as you see in the video. Also, it's made out of a soft material so that it can deform, and it's very safe to use. As you mentioned, safety is our first rule about the design. And by rolling inside your stomach's tissue surface, the doctor can stop it, and then by controlling the external force, you can indeed eject a drug. Here you see this blue thing is a drug.
It made a little pee or something.
Exactly. And it can do this many times. And it can actively image your body so that you can see where you want exactly.
Do it again. Let's see what's it again. Well, first of all, who is running? It looks like it's got a will. Like, is it being driven by something?
You see that there's an external magnet that the doctor has full control of. And indeed, it's moving outside, like you use a magnet outside your body and it's moving the robot inside your body.
Oh, so there's a doctor outside of you with a magnet, and then there's this little thing wobbling, and so the doctor is moving it.
Exactly. That's why it's safe, so that you don't have any, decision.
Is the doctor squeezing out that blue juice?
Yeah. So doctor says that area has a disease, so that he or she decides to eject the drug at that point. And also, the same robot can do biopsy, so it can cut some.
Whoa! Wait a second. It's a 3-in-1. It can take pictures. It can leak, or whatever that is, pour, and it can cut?
Yes.
With what? What is it cutting with?
So the biopsy is a common procedure in GI tract that you want a small piece of your tissue to decide if there's a disease or not. Because sometimes camera images are not sufficient or wouldn't tell you the level of the disease. So doctor needs to take a piece of your tissue and do analysis afterwards. So that we need to pick up this capsule later and do some analysis, which is a little bit dirty.
Well, wait a second. Does it have a knife in its pocket, or like where is the cutting thing?
It's inside the middle, so it's very safely located, so it doesn't cause any damage. But as in the drug releasing case, when a doctor controls the force and presses this thing on purpose, the knife comes out and gets a small.
It's like a switchblade, sort of.
Yes, exactly. Yeah.
Whoa. And so you can then take a little bit of something and then bring it to the doctor.
Exactly.
How do you, I'm assuming that you bring it to the doctor in the old-fashioned way?
In the biopsy case, yes, you need to pick it up coming out of natural ways. But other cases we don't pick
That's
it up.
the intern does that, or who?
That's the cost of high technology.
I see.
Thank you for watching my presentation, and for more information on the content that we talked about, here's how it works.